Welcome to Math is Fundamental. Today we're going to be talking about congruence transformations. All right, so congruent figures are two figures that are congruent, or two figures are congruent if and only if there's a sequence of one or more rigid motions, or we can call those isometries, is another word for rigid motions that maps one figure onto another. Now, rigid motions were defined in a previous video, but just a quick recap, it means that you take one figure to another and it doesn't change size or shape, so you use transformations to do that. All right, so let's look at an example. Which pairs of figures in the grid are congruent? And then for each pair, find a sequence of rigid motions that maps one figure to another. So I'm just going to give one of these examples. So let's look at this one. A, B, C, and J is congruent to X, W, Y, and Z. But when we write our congruence statement, we have to be really careful. If I have A, B, C, J, I need to make sure when I write the other one that I write it in corresponding order. So which point corresponds to A? Well, that is going to be W. B corresponds to X, C corresponds to Y, and J corresponds to Z. So we need to make sure that we write them in the correct order, or it won't be a correct congruent statement. Now we want to find a sequence of rigid motions that gets us from one to the other. There's a lot of different ways we could do this, so you kind of just have to pick one and go for it and make sure it works. So what I'm going to do is I'm going to take A, B, C, J, and I'm going to translate it over 1 to the right and up 5 so that it ends up like this. If I draw my middle step, that's what that's going to look like. I'm going to translate it over and up there. So that would look like this, big T, and then we've got our little arrow brackets, and I went over 1 to the right and up 5. All right, and then I want to compose that with a reflection now across the y-axis. So reflection is capital R, and then I could either write the word y-axis or I could write the line x equals 0. So remember, when we do compositions of isometries like we showed in our last video, we have to write them in kind of backwards order. So if I move it first, I translate it first, 1 over 1 up 5, I want to write that second. And then I'm going to have my pre-image, A, B, C, J equals W, X, Y, Z. And again, yours might be a little different, but that's the way I went. All right, and you can try the other ones on your own if you'd like. All right, here we go. So, conclusion, because compositions of rigid motions take figures to congruent figures, so they're still congruent, they are called congruence transformations. All right, so last example. In the diagram at the right, we know that these two things are congruent, and it tells us which order. J corresponds to E, so J needs to go to E. And Q corresponds to W, so Q has to go to W. So kind of color coding these to make it a little easier to see. V goes to T, so V has to go all the way to T. And sometimes if color coding helps see that if there's like a reflection or rotation that happened in there. All right, so we want to sketch the middle step, kind of like I did in the last problem, and then write a rule for the congruence transformation. So let's look at this graph. So figure out, how could I go from one to the other? Well, let's just look at E and J. If I go from one to the other, we could think of it as a translation, but if we look at the figure itself, it actually needed to reflect and translate. So we might be able to do those two simultaneously, but we have to really be careful which one do we need to do first. So let's see. I think the way I want to go with this is, so if we do each one of these, all right, so I drew my little things. I think I want to reflect it first and then translate it. I think that might be my best bet. So if I reflect it first over the y-axis, I end up with this, and I'm going to name it E double prime, W double prime, and T double prime. I guess I could have used single primes, but that's okay. All right, so if I reflect it across the y-axis, that's going to look like this. Okay, and then I can take those points, and now I can just take them straight down. So E goes from, let's see, from 1, 2, 3, positive 4, down to J, which is at negative 1, so it needs to go down 5. And let's just make sure all the other ones go down 5 as well. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So yes, at this point, I just need a translation, 0 horizontally and negative 5 in the vertical direction. I need to put my original, my pre-image, JQV, and then make sure, oops, except look at what I just did. My pre-image wasn't JQV. My pre-image, I decided to start with TEW or EWT. We want to make sure we really put which one we started with. I could have started with the other one. There's nothing telling me that I couldn't, but if I did that, I might not have the same, I won't have the same transformation. So we have to be really specific. I started with EWT and I ended with JQV. So yours might be completely different than mine, but there's one example on how to figure out how to get from one to the other and write your own congruence transformation. All right, and that concludes our lesson for today. Thank you so much for watching, and remember, math is fundamental.